In this video, we'll take a look at how to run a hierarchical regression analysis. And hierarchical regression is really a very interesting procedure. You can do a lot with it. The more one gets familiar with what this procedure is doing, it really can unlock a lot about regression analysis in general. And you can really use it to start to better understand the role of your individual predictors in the analysis. But the procedure itself is typically used when we want to assess if a predictor, or really one or more predictors, accounts for a significant amount of unique variance, and the key here is above and beyond one or more predictors that have already been entered into the model. So we're looking if a predictor, when one or more predictors is entered second, does it account for significant amount of additional variance above and beyond the predictor or predictors that were entered first? Okay, now in this first example, we're going to take a look at really the simplest case, and that is where we have two predictors, SAT score and social support. And you've seen these predictors before. And then we're predicting, once again, as before, college GPA. Now, hierarchical regression is very flexible. We can use it with as many predictors as we want, as long as we have sufficient participants. But we can run it with 5 predictors, for example, 10 predictors. There is a limit to how many predictors you want to use as they start to go after competing variance, and there's diminishing returns typically after really more than a handful of predictors in most cases. But there's really no limits mathematically in terms of how many predictors you can use, and that's the point I really want to make. But we do want to be cautious about using too many predictors in our regression analysis, because they really do start to compete after the same variance, and they can cause problems in the model if we enter too many. But generally speaking, hierarchical regression is very flexible, and it really is quite a useful procedure. So let's go ahead and get started with this example. And I think as we move through this example, you'll start to get a better idea of how this procedure works, and really how it could be useful for many research applications. Okay, so in this example, what we're going to do is we're going to look at letting SAT enter the model first, and then after that we're going to follow with social support. So in other words, we're going to have 2 regression models, or 2 regression analyses, where our first model, or first regression analysis, is just SAT. So does SAT predict college GPA? And then our second model will also include social support. And because SAT is already in, it stays in the model, but then social support is also added. So to review, in our first regression analysis, we have SAT that goes in, and it predicts college GPA. Then after that's run, we bring in social support, and that also predicts college GPA along with SAT, which has already been in the model. Now, when we do this in a software program like SPSS, we don't actually have to run it twice. There's a way to set up, which I'll show you in just a few moments, where it just does it automatically. But you really do want to think about this as 2 models. We have a first run, model 1, just SAT, and then we have a second run, model 2, that has SAT and social support. Now there's some key tests in hierarchical regression that we want to take a look at. And the first test would be a test of just model 1. And in this example, that means really is SAT a significant predictor of first-year college GPA. So we get a first single test of SAT. And the reason why we get that is because, as you recall, we allow SAT to enter the model first. And then next, because we allow social support to go into the model next, the next test is, do SAT and social support, when taken together, do they significantly predict first-year college GPA? Okay, so that's testing the 2 together. And then here's the test that really is of the most interest compared to just standard multiple regression. And that is this third one here. Does social support account for a significant amount of variance above and beyond SAT scores? Okay, now that may sound familiar to you from our standard multiple regression analysis, from our coefficients table. And if it does, that's good. It is testing really the same thing in this case. Something that's important to recall here is that we're taking the simplest example we can, where we have two predictors. But recall that hierarchical regression is very flexible. I could have put three predictors right here, so SAT and then social support, another predictor, and another predictor. They could all enter in at model 2 if we wanted to. Or I could have two predictors in this model 1 and then two new predictors. Here's one and then some other one in model 2 if I wanted to. So once again, we're just starting with the most basic example, but you can really build with this. And then whatever predictors were entered in model 2, then we would say, does social support and the other predictor account for a significant amount of variance above and beyond SAT scores, and so forth. And the reason why this is called hierarchical regression is because there's an ordering in which we enter our predictors. So there's this ordering, or in other words, there's a hierarchy in which our predictors are entered into the analysis. And from a theoretical or research perspective, this analysis can come in quite handy. And it most often is used in a situation like the following. In this case, we're very well aware that SAT score tends to predict college GPA. We know that from a historical analysis. In other words, for many, many years, colleges have been using an SAT score as a predictor of first-year college GPA. And it's really quite an effective predictor. So that's well known. Okay, so suppose we're doing research in this area, and we say, well, we know that SAT score predicts college GPA. But let's suppose that people haven't looked at social support yet. So our new study here, hypothetically speaking, is that we know SAT predicts GPA. But suppose that we're the first researchers looking into social support as a predictor of GPA. So what we want to do is not just run a regression analysis using social support to predict GPA, but because the field already well knows that SAT score predicts GPA, what they want to know is, does social support add any predictive utility or predictive ability in terms of GPA? So, in other words, adding social support into the model, does that account for a significant amount of unique variance in GPA, even after SAT has already been entered? So does social support help predict GPA further? And this is really a very common application for hierarchical regression. So hierarchical regression is really useful when you're working in a certain area and one predictor has already been established in the field, and you're looking at a new predictor, or maybe a set of predictors, and you want to see if those new variables account for additional variance above and beyond the already established, well-recognized predictor or predictors. So it's really quite a useful procedure for that context. Okay, so let's go ahead and get started and run this analysis. So recall that we're going to enter SAT score first and then social support afterwards. So let's go to Analyze and then Regression and then select Linear. And then here we have college GPA as our dependent. And then SAT score, recall, is entered first because that's already well established, right? We all know SAT score is effective at predicting college GPA. Now the way we run the hierarchical regression is that we click on this Next button. So go ahead and click Next. And then now we're going to move social support over. And notice here it says Block 2 of 2. So that looks good. Okay, let's go ahead and click OK. And then here we get our output, and you can tell, compared to multiple regression, it looks a little bit different. Same tables, but now we have two models. So here, Model 1, Model 2, Model 1 and 2, Model 1 and 2, and Model 1 and 2. Okay, so let's take a look at these results. So notice here, Model 1 says SAT score, and then Model 2 says social support. But because SAT score was already entered into Model 1, in Model 2, this is showing that we've added social support. but just be aware that SAT score is also in there. And then here our model summary table. So here we have an R-squared for model 1 of 0.38. So you want to ask yourself, what is that R-squared referring to? Well, if we look down here, notice the A, the superscript. We have predictors SAT score. So once again, SAT score was entered into model 1, and that was it. So SAT score has an R-squared of 0.38, or it accounts for 38% of the variance in first-year college GPA. And then model 2, we have an R-squared of 0.491. And remember, model 2 is SAT score and social support. So notice, even though in this first table we had just social support listed for model 2, here SPSS shows, in fact, that model 2 does have both of these variables. So R-squared of 0.491, when SAT score and social support are both in the model, they account for, collectively, 49% of the variance in first-year college GPA.